So we're in section, this is 6.5. What makes a rectangle or a rhombus? And it says on your graphic organizer, well, we're starting with a parallelogram. We have a parallelogram. So somehow we figured out, or we've been told, that these things are parallelograms. So let me go down to the second page. There we go. So these first two are about what we need to know that we have a rectangle. So again, we're starting out with a parallelogram. So somehow we've figured it out, the figure's marked, we know this is a parallelogram. So you might want to mark for these problems that the opposite sides are parallel. If one angle of our parallelogram is a right angle, then it's a rectangle. And I'm just going to mark one of these. I'll mark angle A. So we could say if angle A is right, it's a rectangle. And it could be any of those angles. So if we have a parallelogram with one right angle, then it's a rectangle. All right, the next one. The next one is called the house builder theorem. I'll talk in just a second about why. If the diagonals of a parallelogram are congruent, then it's a rectangle. So somehow we figured out, we've been told that this is a parallelogram. The diagonals are congruent. So there are the diagonals. So we're saying if AD is congruent to BC, segment BC, then it's a rectangle. The reason that they call this the house builder theorem is because anthropologists have found with existing primitive cultures, and we have evidence from like archaeological evidence that when people wanted to build some kind of structure, they would use logs or ropes or something that were the same length to make sure that they laid out the foundation of their structure in a rectangle. So they made sure the diagonals were congruent to make sure their foundation was a rectangle. So that's why we call it the house builder theorem. So people have known this idea, maybe not as a geometry idea, but as a building idea, for a long time. It's kind of an interesting fact. All right, we have those two. Okay, the next ones have to do with rhombuses. So let me grab two of those. So we're still starting with parallelograms. If one pair of adjacent sides is congruent, then the parallelogram is a rhombus. So we know somehow that this is a parallelogram. And we know that one pair of adjacent sides is congruent. So I'm going to mark these two sides congruent. Then it's a rhombus. So in symbols, if AC, segment AC, is congruent to segment CD, then it's a rhombus. reason we know it's a rhombus if two adjacent sides are congruent is because we know it's a parallelogram, so opposite sides are congruent. So these two sides would be congruent. Well, these two sides are also congruent, so they're all the same. Next one. If the diagonals of our parallelogram bisect the angles, then it's a rhombus. So we know it's a parallelogram. The diagonals, there are diagonals. And I'm going to mark our angles, so the way we know that the diagonals bisect the angles is if those two are congruent. Well, that means these two would also be congruent. And those would be congruent. And I'm not going to write all the symbols, but I'm going to say, we could say if AD and segment BC bisect the angles. Then it's a rhombus. So bisect the angles, you know these are congruent. You might be told in various different ways that the diagonals bisect the angles, but that guarantees us that we have a rhombus. All right, we good there. The last one. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So we've figured out, we know, we've been told that this is a parallelogram. And we also know that the diagonals are perpendicular. So I'm going to make that a 90-degree angle. So that guarantees us that this is a rhombus. So I'm going to say if segment AD perpendicular to segment BC, then it's a rhombus. All right, questions? Okay, I want to look at a couple of examples that have to do with rhombuses or rectangles. This is the kind of thing that we're going to be doing on with our whiteboards, identifying, classifying these quadrilaterals. So for both of these, I want to know, is this a rhombus, a rectangle, or square? And we know we're starting out with a parallelogram. So here's our first example. I'm going to say that's 7, 7, 7, 7. This is a parallelogram. All right, so we want to know rhombus, rectangle, or square. Well, what are these numbers telling us about? What parts of the? They're telling us something about the diagonals. So what's this whole diagonal? 14. What's that whole diagonal? 14. They're congruent. What does that tell us about the parallelogram? It's a rectangle. It could be a square if all the sides are the same, but we don't know the lengths of the sides. So I'm saying diagonal congruent, so it's a rectangle. How about this one? And again, don't go by what the picture looks like. Go by what the information tells you. Sometimes they'll draw pictures that look like this. They'll look like a parallelogram. They'll look like it can't be a rectangle or a square. But the information that they give you tells you that it's a square. So the picture can be tricky. So there are my diagonals. We know this is a parallelogram, so I'll mark the sides parallel. Remember, the arrows mean parallel. And I'm going to say this. Parallelogram, perpendicular diagonals, makes it a rhombus. All right, questions? Okay, homework for today. So again, we're going to do, after I answer questions, we'll do some practice with whiteboards, and then we have a little activity that we're going to work on. So our homework. There we go.